Hello, welcome to Chapter 3, Homework Questions 81 through 86. Question 81. Find each of the following products by drawing and labeling a generic rectangle or by using the distributive property. Alright, so for part A, we're going to distribute negative 4y to a 5x and an 8y. So we're just going to use the distributive property. That would give us negative 4 times 5 is negative 20. And then y times x is yx or xy. You'll start seeing the variables go in alphabetical order. The next one is negative 4 times positive 8. That's negative 32, so that's minus 32. And then what's y times y? That would be y squared. All right. If you're using the generic rectangle, you're only going to have one level here. You're going to have a negative 4y, and then the 5x plus the 8y. So it'll look like that. On B, same idea. We have 9x times negative 4, so 9 times negative 4 is negative 36. And then it's just x, there's no other variable. And then 9 times 10 is 90. And then x times y is, once again, xy. If you choose to use the generic rectangle, you'll have a 9x and then a negative 4 plus a 10y. So it would look like that, you fill in. But you still have to write your answer in this form. You don't want to just do the generic rectangle and leave it separated into the different rectangles. You got to make sure you simplify and write the expression when you're done. On part C, definitely going to use the generic rectangle. Here we have a x squared minus 2 with 2 terms, and then x squared plus 3x plus 5 with 3 terms. So we're going to have to create something where we have a couple more levels here. So we'll have an x squared minus 2, and then on top we have an x squared, a positive 3x, and a positive 5. So that's going to create 6 different rectangles. All right, here we go. X squared times x squared. Remember, this is x times x times x times x. So you have 4 x's being multiplied together. So it'd be x to the 4th power. Negative 2, well, I'll work this way. I'll work across. X squared times 3x, so that's x to the 1st power. So 3 times 1 is 3. X squared times x to the 1st is x to the 3rd. 5 times 1 is 5, and then we just have an x squared. Now on the bottom row here, we have negative 2 times x squared, so that's negative 2x squared. Negative 2 times 3 is negative 6, and then x to the 1st power, since that one doesn't have an x. And negative 2 times 5 is negative 10. Now we need to make sure that we are combining our like terms. So you'll notice we have, on this one, is that right? We have an x squared here, and then we also have, no, I guess that's it. I thought there was another one, but it looks like that's it. So we'll combine those, and our final answer is we're going to write it with the highest exponent first. So x to the 4th is the highest. Then we have an x to the 3rd, so that's plus 3x cubed. And then negative 2x squared plus 5x squared, that means there's a total of 3x squareds. And then minus 6x, and then minus 10. So that would be our final answer on that one. So a little bit lengthier on that one. Just the more terms you have, the bigger the generic rectangle is going to be, but it works every time. Question 82. Is the set of even numbers closed under addition? That is, if you add 2 even numbers, do you always get an even number? Is the set of odd numbers closed under addition? Explain your answers. So for even numbers, as you're kind of working through this and trying to think, is it possible when I add 2 even numbers, 2 plus 6, is it true that I will always get an even number back, even if you do 102 plus 96? All right, so far it seems to be working. And as you think about that, if you start with an even number, and you're adding another even number to that, and even if you think about it on a number line, that might help as well. You're always going to add another even number. So if you start with an even and you add any multiple of 2 here, which is what all the even numbers are, you're always going to get to another even number. So yes, even numbers are closed under addition. All right, what about odd numbers? If you add 2 odd numbers, are you going to get an odd number back? So we'll just start with 1 plus 3, and you'll notice right away you get an even number. So definitely doesn't work. What if you add couple other odd numbers. What do you notice actually about every single time that you add an odd number? It appears that you're given an even number back. And if you think once again on a number line, if you're adding another odd number, every odd number can be broken up to an even number plus 1. So what you're really doing is adding, let me fix that real quick. So this would be 98 plus 1. So you're adding two even numbers plus 1, and you're adding it twice, so it actually is plus 2 every single time, so it's always going to get you back to an even number. So on this one, it is no, odd numbers are not closed under addition. And so once again, just make sure you are explaining your answers. Question 83, find the dimensions of the generic rectangle at the right. Then write an equivalency statement, length times width is equal to area. Of the area as the product and as a sum. So as you're looking at this, x squared, so if that's an x squared, we have to have a length of x and x. To get negative 5x, x times what? So this length right here is x. So what times x gives you negative 5x? That would be a negative 5. On this one, this side we know is x from above. X times what gives us 3x? So that would be a plus 3. And then you'll notice 3 times negative 5 is negative 15. So we're going to have a length of x minus 5. A width of x plus 3, and that is equivalent to those tiles, which is x squared, don't forget combine your like tiles, minus 2x minus 15. So this is the equivalency statement that we're looking for in all these problems. This is the product, which is the length times the width, is equal to the sum of the parts. Question 84, solve for x. Use any method, check your solution by testing them in the original equation. So for part A, we want to solve for x. Remember with absolute value, as I cover this up, what numbers could we replace inside here? So we could put a 5, that could be a 5, the absolute value of 5 is 5. We also could put a negative 5 because the absolute value of negative 5 is 5. So what that means is when I take this and move this away, well, that means whatever that expression is, in this case x minus 3, it could equal negative 5, but it also could equal positive 5. So when we solve these two equations, we get x equals 2 and x equals negative 2 and x equals, wait, hold on a second. Oh, I changed my sign. Let's fix that. It's supposed to be a minus 3 here, not a plus 3. So x minus 3 equals positive 5, so x is equal to 8. And so those are our two solutions. We can plug those back in to check to make sure they work. Is it true that the absolute value of negative 2 minus 3 is equal to 5? And you'll notice that the absolute value of negative 5 is 5, which is what we were looking for. And then if we do it again with the number 8, it's 8 minus 3, and that gives us positive 5, and the absolute value of positive 5 is also 5. So it checks. So we have x equals negative 2 and x equals 8. So we have two solutions there. All right, on to part B. 5 times the absolute value of x is equal to 35. So it's important that we understand that we really need to get the absolute value by itself. Now in this case, you might have it figured out. 5 times what is going to give us 35? Well, that has to be 5 times 7. So we need that x to be a negative 7 or a positive 7 because we know 5 times some number is 35. We know that has to be a 7. So we know that the absolute value of x must equal 7. So that gives us two answers. X could be negative 7 or x could be 7. Another way we can write when we have multiple solutions is we can write it in a solution set x equals, and we can use the curly bracket. And we just put them in numerical order, negative 7, comma 7, and then we close it with a curly bracket as well. So it's another way that you might want to write it. Just makes it a little bit more kind of official. C, we have the absolute value of x plus 1 is equal to 2. So once again, if we think about this, what number can I place inside here to make this a true statement? We could place a 2 or a negative 2. And so therefore we can just set up an equation. If that's the case, then we want to know when x plus 1 is going to equal negative 2, and when is x plus 1 going to equal positive 2. So when x is negative 3, that happens, and when x is 1, that happens. So if you plug in negative 3 plus 1 is negative 2, the absolute value of negative 2 is 2. If you plug in 1 plus 1 is 2, the absolute value of 2 is 2. So it does work out, and you'll just start to see me typically write these in this solution set form, but either way I'm sure is fine. And on to D. So the absolute value of x plus 3, the quantity of the absolute value of x plus 3, is equal to negative 2. Now we could go ahead and set up our two scenarios, but once again, if we're thinking about this instead of just going through and doing the math, what number can I plug in here so that when I take the absolute value, I get a negative 2? And if your answer is, well, you could plug a 2 right there. Is the absolute value of 2 negative 2? And the answer to that is no. The absolute value is a distance. Well, then you're like, okay, well, then I'm going to plug in negative 2. Well, is the absolute value of negative 2 equal to negative 2? And once again, the answer is no, because absolute value is a distance. So, can this work out? Is there some solution where this would work? And the answer is no, because we can't have an absolute value equal to a negative distance. So on this one, there is no solution. There's no value for x that will ever work for part D. Question 85. Copy and complete the diamond promise below. The pattern used in the diamond problems is shown to the right. So remember, we have multiplication, maybe, on top, and addition on bottom here. All right, on part A, if we don't know what x is, what times negative 1 gives you negative 4? And that would be a positive 4. 4 times negative 1 is negative 4, and then we can add 4 and negative 1 to get a positive 3. On B, you have your x and y, so x times y, negative 4 times negative 4 is 16, negative 4 plus negative 4 is negative 8. On C, we don't have the x again, but we do have the addition, so x plus negative 3 is equal to 8. So if I add 3 to the other side, x is equal to 11. So does that make sense? If I put 11 here, 11 plus negative 3, is that equal to 8? Yes, and then 11 times negative 3 is negative 33. And then on the last one here, we don't have the x or the y. We don't know either one of them. So now we got to kind of answer a little different question here. X times y has to give you negative 7, but then x plus y has to give you 6. So since there's less factors of negative 7 than there are the sum of 6, what things multiply to give you negative 7? Well, you could either do 1 times negative 7, or you can do negative 1 times positive 7. Which one of those adds up to 6? And that would be negative 1 plus 7. That's going to add up to 6. So it looks like our answers for this to work out is to have a negative 1 and a positive 7. And you could move the order of those is fine, but the negative has to be with the 1. If it was with the negative 7, we would get a sum of negative 6, not positive 6. So you got to make sure you got the negative 1 and the 7. Question 86, if f of x equals 7 plus the absolute value of x, and g of x equals x cubed minus 5, then find each of the following. Pay attention. We have an f function and we have a g function. So it's important that you're looking at the right one, the correct one. So f of negative 5, give myself some room here. I'm going to plug in to the f function right here. I'm going to plug in negative 5 wherever there's an x. And then I'm going to evaluate. 7 plus the absolute value of negative 5, which is 5. 7 plus 5 is 12. So my final answer is f of negative 5 is equal to 12. B, g of 4. So plug it into your g function. So g of 4 is equal to 4 cubed minus 5. So 4 cubed, 4 times 4 times 4 is 64. 64 minus 5 is 59. So g of 4 is equal to 59. C, we're looking for f of 0. So back to the first function. That would be 7 plus the absolute value of 0. And the absolute value of 0 is 0. You're 0 away from 0, so f of 0 is equal to 7. On part D, we have f of 2. So that would be 7 plus the absolute value of 2, or 7 plus 2, which is equal to 9. So f of 2 equals 9. Part E, g of negative 2. And that is, since x is being cubed and x is now negative 2, we need to make sure we put that in parentheses. Negative 2 cubed minus 5. Negative 2 cubed is negative 8 minus 5, and that's negative 13. So g of negative 2 is equal to negative 13. And then the last one, we have g of 0. So that would be 0 cubed minus 5. 0 cubed is 0. 0 minus 5 is negative 5. So g of 0 is equal to negative 5.